In this lesson, you'll learn to write an algorithm that searches through an array list and removes all target values. We start with the class shopping list. It has an instance variable, items, that is an array list of string. Here's a constructor that initializes the instance variable. The body of the method, remove an item, is currently empty. We're going to write our algorithm here. The method has a string parameter item to remove. We'll search the array list items for strings matching item to remove and remove those indexes. In this program, we are traversing an array list of string, so our parameter is a string. If the array list held a different data type, the parameter item to remove would need to match that data type. This version of the remove an item will modify the items field, but won't return anything, so its return type is void. We will start by writing a loop to go through each index of the array list. Normally, when we traverse an array list, we start at the beginning and go to the end. However, when an item is removed from an array list, everything after it slides down and the indexes are reassigned. This can result in skipping over an element when the previous one is removed. The easiest way to avoid this is to start at the end. The last index is always one less than the size, so we'll start at size minus 1. The first index will be 0, so we want to continue as long as I is greater than or equal to 0. After each cycle of the loop, we will decrease I by 1. Inside the body of the loop, we create an if statement. We call the get method from the ArrayList variable items and retrieve the object at index I. How we proceed from here depends on what type of objects the ArrayList holds. This ArrayList will return a string object, so we'll use the equals method from the string class to compare it. All object types have an equals method, but they don't always work the way we want. In the case of the string class, the equals method works properly. We pass the parameter items to remove to the equals method. If the string in index I is exactly equal to the string in item to remove, the equals method will return true. The equals method will also compare capitalization, so if you don't care if the capitalization is the same, use the equals ignore case method instead. If this were an array list of integers or doubles, we could use comparative operators such as greater than, less than, double equals, etc. If the object at index I matches the object in the parameter item to remove, then we want to remove that object. We will call the remove method from the items variable and pass it the value of I. This will cause it to remove the object at whatever the current value of I is. All objects after it will slide down into the empty space and have their indexes renumbered. Now let's look at a variation of this algorithm. Let's say we want to keep track of how many objects we removed from the array list and return that value. First, we change the return type from void to int. Next, we create a count variable and start it at 0. Every time we remove an object, we increment count by 1. Finally, after the for loop completes, we return count. Next, let's modify the algorithm to search for partial matches. For example, if a string in the items array list is hot dogs and items to remove is dog, that would be considered a match. To do this, we will replace the equals method with the contains method. An alternative way to do this is to use the index of method and check if it returns the value not equal to -1. A value other than -1 indicates that item to remove is somewhere inside the string at index I. Finally, let's modify the algorithm to return an array list containing all of the removed values. We change the return type to ArrayList of string. Next, we'll create an empty ArrayList of string to store the removed items. When the remove method is called from an array list, it returns the object that was just removed. Right now, we aren't doing anything with that returned object. Let's store it in a string called temp removed. If instead of being an array list of string, items were, for instance, an array list of double, then temp removed would be a double variable. Now, we'll call the add method from the removed items variable and pass it temp removed so it gets added to the end. Finally, we return the removed items array list. We still have the count variable even though we are no longer using it. If you want to learn more, click on the thumbnail for the next video. Otherwise, check out the full Java playlist. See you in the next video.